Hello, statistics student. This video is for chapter 3.1, compound events. So other than simple event like one things that you want to watch for A, to find probability, which is how many way A can happen over the total number of way. We also have three compound event, like more complicated event. So the first one is an event that's involving two simple events, but combine it with the terms or. Now, or is not an English or, is more like a logic or mathematics or. So if we say I want to find the probability of A or B, that means the favorable outcome or the successful outcome is the number of ways that A happen, B happen, or both A and B happen. Okay, and then of course the sample space is still the total number of way for that one procedures. So this is about one procedures, but your outcome can include multiple things. For example, if you throw a dice, you want to say, I want to find the probability of getting a 1 or a 2. So that is the meaning. Two simple event. Getting 1 is a simple event. Getting 2 is a simple event. 1 or 2 is getting either 1 or 2 or both. And of course, in those cases, 1 and 2 is not possible, right? So the other way of combining two simple events to look for an outcome is saying A and B. Now, again, this and is not the English and, but logic and. So you can say it's a special terms that statistics or mathematics used. Doesn't means in the normal English way. So when we say in probability A and B, that means I want to look for ways that A and also B occur at the same time. So what does it mean? So you will be looking at the features of a subject, but well, actually not a feature of a subject, two features of a subject. So for example, as students, I want to see what is the probability of getting the student is a female and also take statistic. So the gender is a feature and the classes that the students taking is another feature. So A and B means it satisfies both A and B occur. So either a female and also taking statistics occur. So so the number of way is you want to find those that has both features. So remember thinking of both happens together. Okay. The third compound probability is involving conditional probability, like in steps. So the event is written as given as a condition. So this word given, if you see it in a probability statement, is showing or it's illustrate that B has happened. B is a condition, has occurred. So you want to find what is the chance of A will happen now that B has already happened. Okay, so maybe you can say, well, what's the chances today it's going to rain? Now I see that the cloud is, there's cloud, it's cloudy versus what is the chance of today it's going to rain? No, without knowing what other conditions. So the condition as given as is the something that has happened, and you are to find the probability that and another things A can happen. And in terms of the form, now you do not write A or B or A and B, you write A/B. So you use a vertical line in the keyboard. It is just a vertical line to to illustrate this sentence of A given B. Sometimes we call it A given B. Sometimes we use the word given as if we're doing the or and the symbolic way is this vertical line. So how do you do it? You actually change the sample space. The sample space would be all the way that B can occur because B has already happened. So you only need to count the number of ways that B occur, and then the top would be both A and B occurs. So this is how you would do it. So this is in a way, there is a conditional probability formula. We'll talk about this in, I think, 3.3 also. But for the time being, you can think of to find probability of A given B is to find how A and B both occur because B has already occurred. Now A has to occur, so it's A and B. over a new sample space. The sample space is not all the different way, but the sample space of B only, as B only. So how many way can B occur? Because we assume that B has happened. So let's practice doing or, and given. So basically these three things. The first example is there's a spinner, and then we want to find probability of 5 or 6. So the spinner can land on one place only, right? So spun once. So you spin it only one time. So it would either have 5 or either a 6. So what are the chances that would satisfy this? When we say or is either one of them, so there's two cases of 5 or 6 or both. So in this case, it's 2 out of the total way is 6 or 6 cases of the total possible sample space. So that is 0.33 or 1/3. Second example is 6 face dice, and you want to find probability of you toss it once, and you want to find probability of getting a 4. So probability of 4 is there's one way of getting 4, so it's 1/6. We talked about those before. Probability of 4 or 5. So write it as 4 or 5 is you can do 4 or 5 or both, but there's only just two cases of 4 or 5. So it's 0.33. What about 4 and 5? That's not possible. You cannot have, when you throw a dice, is either one of them. You cannot have both happening. Oh, this is a wrong one. It's a typo. So 4 and 5 is 0. So it's not possible to have them because 4 and 5 are mutually exclusive. Okay. D, 4, given that the outcome is an even number. So if it's an even number, I will use the even number as my sample space and think about how likely it is a even number and a 4. An even number and a 4 is just one case because it has to be a 4. And the sample space of all the even number is only 2, 4, 6, right? So there's 3 numbers. So you have it divided by 3 instead of 6. So it is 0.33. Probability of a prime number has nothing to do with and or a given. So what are the prime numbers? 1 is a prime number. No, 1 is not a prime number. 2 is a prime number. 3 is a prime number. 5 is a prime number. So it's 3 out of 6.5. I think the last one does not involve any and or or. So let's practice more and or. So it's the marble jar things again. I have 5 red, 3 blue, and 7 white marbles. So totally, the grand total is what? Grand total is 3 plus 5 plus 7. So that is 8 plus 7 is 15. So if I select one marble, what is the probability that it is a red? So how many will satisfy red? Is 5, right? How many total weight? 15, so it's 0.33. What is the chance it is not red? So blue and white are not red, so I add them together. So these are the way that would satisfy not red. So 10 over 15 is 0.667. Okay, so let's practice or, and given. Red or blue? Red or blue means either it is, I pick one marble, it is either a red marble or a blue marble. So I will have 8 chance of satisfying this. So it's 8 out of 15 is 0.533. Can I pick one marble and it's both a red and blue? No, marble color is just one, right? So it's 0. Can I have red given is a blue? If you have a blue already, um, um, this is a blue, so it's not possible the marble suddenly change into a red. So remember, it's one marble, not before, okay? Not before. Not the fact that you have this happen before. When we do 3.2, we'll talk about the step one. Step one is a blue, and then I get a red. So we will talk about those. But in 3.1, it's all about just one marble, okay? Just one procedures. So another example is about playing cards, a standard deck. So remember, standard deck has 4 suite. Red cards, diamond, just review because not everybody playing card now. Hearts, these are red cards, and they have A, 2, 3. A is 1, right? All the way to 10, and then Jack, King, Queen, Jack, King, Queen. So that's 13 card. Hearts is also the same, and then black cards are club, or space, also this 13 card. So there were 4-2, 4-3, 4-10, 4 king, 4 jack of all different suite. What is probability is a black. So we have to look at how many black cards there are. Clubs and spades are all black cards. So it's 26 over 52.5. Okay. Black and a 6. So what cards are at the same time black and also 6? Well, club and spades has 6, right? Both are black. So I have two chances that can satisfy this. Remember, and means I need both of them. Not all the black card, not all the 6 cards. So don't think of this as English and. It's a logic and saying that I need to satisfy these two. The card that one card that I drawn is both a black and a 6. Does that make sense? So I only have 2 of this. So 2 out of 52 is 0.0385. What about black or 6? Logically, by definition, black or 6 means either it's a black card or 6. This I am successful, okay, or both. So let's count how many are black or 6. So I count all the black cards because I just want black or 6. So long as I have some black card is fine. So it will be 26 or the black, right? And then after I do this, in the red one, there's 2 6. That will satisfy my requirements. So I add this 2 red 6. So I have 28 over 52 is 0.5385. Okay, distinguish or and in probability. Or means I don't care, just give me some of these. And means I'm very strict. I need to be both. Okay, kind of like admission. You have to have take this and this. But in applying for this college, you can have this class or that class. So that is the meaning. D, king given black. King given black means I have a black card already. What is the chance I have a king? How many black? So that means whenever we are doing given, I have to change my sample space not to use the grand total, but only those that has given. How many black card do I have? I only have 26. So I say 26 as my sample space instead of 52. And then how many black card are in the king, in the black? So there's 2 king only, so it's 2 over 26. Okay. So this slash means given. What is the probability I will get an A? Given that someone tell me I already know, so for some reason I have a diamond. So if you have a diamond, there's 13 cards that's available as your sample space, and there is only one A, right? A means 1. So it's 1 over 13.0769. What is the probability it's not a face card? Not means or the other card that is not Jack, King, Queen. So we would have 10 of those, 10 of those, 10 of those. So it's 40 of the not face card. Out of 52 is 0.7692. Okay. So this is the way to calculate probability by the definition. We call it calculate and or by definition. In 3.3, we'll actually revisit this by using formula, but you don't really need to. Using the definition is good enough. So in the next video, which is part 4 of 3.1, we'll talk about calculating or and given using a contingency table.